So let's go to the next chapter, which is introduction to determinants. So we had done the determinant of a 2 by 2 matrix. Then now we want to do the determinant of more than 2. More than 2. Okay, so let's start from the notation. So we can say we will determine the determinant of an n by n matrix, where if we have the n by n matrix to be of this form, so A11, A12, all the way to A1n, A21, A22, A2n, and then AM1, AM2, then let's say n, let's use N1, N2, and then N. That is an n by n matrix. So we write the determinant as, so the determinant, then determinant, which we can write as determinant of A, is equals to A11, A12, A1n, A21, A22, A2n, and then AN1, AN2, ANN. So we write it like that. So that is how we write the determinant. So if you find the absolute value, okay, now let's start the first section. Let's start from section 1, which you can say the n by n determinants. N by n determinants. So we want to start from section called the submatrices. So what is a submatrices? Submatrices. So if we assume that n is greater or equals to 2, the matrix is of more than 2, the I and the j, the I and the j submatrix, the I and the j submatrix of A is the n minus 1 by n minus 1 matrix, which will give us Aij, obtained by deleting the ith row and jth column from the matrix. from the matrix A. So a submatrix, we find that submatrix. Then, so we find if this one is an n by n matrix, then we delete, when we delete the ith row and the jth row, then that the remaining matrix will now reduce by 1. Reduce by 1. So that matrix which is remaining there will now be Aij, and this is what we call now a sub matrix. The sub matrix. For example, example number 1. Write out all 2 by 2 sub matrices of A, which is equals to 1, 3, 5, 2, 1, 1, 3, 4, 2. So write out this 2 by 2 sub matrices of that. So to get a sub matrix, then we delete the row and the column. Then to the end. So when we realize that this one has like 1, 2, 3, 4, 7, 8, 9. It has like 9 sub matrices. We have 9 sub matrices. So the solution. There are exactly 9 2 by 2 sub matrices of A. There are exactly 9 2 by 2 sub matrices of A. So to get the first one, which is A11, this is found by deleting. A11 is found by deleting the first row and the first column. So the first row and the first column. So when you delete the first row and the first column, then A11 we get what? So we delete this and that. So it is 1, 1, 4, and what? And 2. Okay. To get a second one, which is A12. A12 is found by deleting the first row and the second column. A12, delete the first row and the second column. So when you delete the first row and the second column, you get 2, 1, and then 3, 2. To get A1, 3, then this again, the same thing, we delete the first row and the third column. So the remaining matrix there is 2, 1, 3, 4. Okay. A21 is found by deleting the second row and the first column. The second row and the first column. So what remains is 3, 5, 10, 4, 2. So what remains there is 3, 5, and 4, 2. A22, delete the second row and the second column. So what remains is 1, 5, and then 3, 2. And then A2, 3, the same way, delete the second row and the third column. What remains is 1, 3, and then 3, 4. Okay, A31, delete the third row, the first column. So what remains is 3, 5, and 1, 1. So we have 3, 5, and 1, 1. A32 equals to delete the third row and the second column. What remains is A1, 5, and then 2, 1. And then A33. What remains is 1, 3, and then 2, 1. So those are the sub matrices. So we form 9 sub matrices of 2 by 2. Any question up to that? So that's how to get a sub matrix. Now we will use this to see how we can use this one to get a determinant. Okay, let's come to the next one, definition 1.2. 1.2 definition. Number 1. If n equals to 1, then the determinant of A, which is equals to A11, is determinant of A, which you can just write as depth of A, which is equals to A11. Determinant of A is A11. It is just 1. Then the determinant of that matrix is same stuff matrix. Number 2, if n is greater or equals to 2, if n is greater or equals to 2, then the determinant of A is determinant of A equals to determinant of A equals to, we can use the first row. Like in this case, we can use this first row here to get a determinant. So we say now the first row multiplied by the sub matrix. So like for example, A11, to get determinant of this, then we say this A11, which is a small A11, multiplied by the sub matrix, minus this A12 multiplied by this sub matrix, plus this multiplied by this. So in this case, determinant of A is the same as A11 multiplied by the sub matrix A11 minus A12 multiplied actually by the determinant of that. Determinant of A11. Okay. So it is determinant of A is equals to A11 multiplied by determinant. So A11 is the entry in the first, so that is the first entry in that matrix. A12 is the second entry. So minus A12 by determinant of A12 plus A13 multiplied by determinant of A13. So then minus, so you continue like that, and then plus minus 1 raised to n plus 1. A1n determinant of A1n, which is equals to, this is the same as the summation, which is the sigma from of j equals to 1 to n. minus 1 raised to 1 plus j, A1j, determinant of A1j. So to get a determinant of A, then you can use the first row, the second row, the third one. So if you use the first row, then it is A11 multiplied by the determinant of the submatrix minus A12 multiplied by the determinant of the second submatrix. Like that. So until the last one, that's row minus 1 and plus 1 there. So if this is even, then this one will be what? Positive. If this one is odd, then this will be. So finally, this is similar to the summation. So you add. So it's just like adding this. So if it is the first one, if j is 1, then it is minus 1 raised to 1 plus 1, which is 2. So it is the first one here. So it is positive A11, determinant of A11. The second one, we put here 2. So minus 1, so 1 plus 2, which would be 3. This is odd. This will be minus 1. And that A12, determinant of A12. So you continue like that. So that is how you get it. Okay. Determinant of A. So provided that all the sub matrices, which are n minus 1 by n minus 1 determinants, which is determinant of A11, determinant of A12, until determinant of A1n are already defined. Okay, let's look at example number 2. Now, if we have a 2 by 2 matrix, so let's use definition to compute the determinant of A, which is equals to A11, A12, A21, A22. So let's use the definition. So here, if we now get the sub matrices. So what are the sub matrices of this? So the solution. So what is our A11? So our A11 is, we delete the first row, and the first row. So it will be what? A22. So A11 will be A22. A12, capital A12 will now be, we delete the first row and the what? And the second column, which will be A21. A21. Sorry. Yeah, A21. A21. Now, using this definition here, now let's get the determinant of that. So to get now the determinant of A, then it is the same as A11. We use the first row. So it is A11 multiplied by what? Determinant of A11. Determinant of A11. Minus, since this is the second one, so it is minus A12 multiplied by determinant of A12. Okay. So what is the determinant of A11? It is what? A11, right? So determinant of A11 is equals to, which is this one, is A22. Determinant of A12 is equals to A21 from this, from the first definition here. So if we have a matrix S, A11, then the determinant of that matrix is A11. So therefore, the determinant of A here will now be A11 multiplied by what? By this determinant of A11, which is A22, minus A12 multiplied by the determinant of A12, which is A21. And that is the determinant of a 2 by 2 matrix. If we remember, so we say determinant of 2 by 2, we multiply this minus this one, right? So it is A11 multiplied by A22. A11 multiplied by minus A21 multiplied by A12. Was it like that? So we can use this definition to get a determinant. Okay, now let's come to example 3 using this example number 3. Compute the determinant of A, which is equals to 1, 3, 5, 2, 1, 1, and then 3, 4, 2. Computes the determinant of that. Now, using the definition. So we have already written the sub-matrices here. So you can either use the second, I will show you how to use the second, but let's use the first one here, okay? Let's use the first one here. So we already have the sub-matrices of A11 here, which are equals to deleting the first row and the first column, which is 1, 1, 4, 2. A12 to be equals to 2, 1, 3, 2. And then A13 to be equals to 2, 1, 3, 4. 2, 1, 3, 4. So now let's find the determinant of A11. So what is the determinant of A11? Since you've converted this to a 2 by 2, then we know that the determinant of A11 is multiplying the row and minus the other one. So it is 1 multiplied by 2 minus 4 multiplied by 1, which is equals to minus 2. The determinant of A12 is 4 minus 3, which is equals to 1. And determinant of A13 equals to 8 minus 3, which is equals to 5. Now, using the definition, then to get now the determinant of A, then it is the same as A11 multiplied by determinant of A11 minus A12 multiplied by determinant of A12, and then plus A13 multiplied by determinant of A13. So therefore, determinant of A is now A11, which is this, which is 1, multiplied by A11, which you already found, minus 2, minus A12, which is 3 here, multiplied by A12, which you already found, which is 1, and then plus A13, which is 5, multiplied by determinant of A13, which is 5 there. This one is equals to minus 2 minus 3 plus 25. Which we get as what? 20. Any question after that? Exactly. The determinant? Yeah. Oh, that's a very nice question. Oh. I can say I don't know. I was one looking. But I feel like the determinant, because we're getting the absolute value, is actually the value of but I'll go and look at it. I'll tell you the next 10 minutes. Okay. So determinant we get from, because it seems like we're writing the absolute value. Okay. Any other question after that? Now, let's come to the next one. We can use the cofactors to find the determinant. 1.3, the cofactor, Cij. Cij. Now, if the matrix is n by is more than 2, then the Ij cofactor of A, Ij cofactor of A is Cij, which is equals to minus 1 I plus j determinant of Aij. And we have determinant of A to be equals to A11 C11 plus A12 C12 plus A1n C1n, which is the same as the summation of j equals to 1 to n A1j C1j. So this is actually similar to this, but now we have, instead of now putting the minus method back here, it is the same thing, but now we are using the cofactor. So we are using this definition here to get the cofactors. So the cofactors are found from the sub matrices. Okay, but the only thing is that we now come and put the minus here. If we are deleting the first row and the first column, then we add the ones which are deleted here. We raise by adding. So this is the one which we deleted. So this is the one which we found by deleting the first and the second, less than the first and the first row and the first column. So to get the cofactors here, then to get this, let's say C11, then it is C11 by deleting the first row and the first column. is the same as minus 1, 1 plus 1. So you see, minus 1, 1 plus. So minus 1 raised to 1 plus 1. So the first one, of course, would be what? Would be positive. And then the one which you deleted. Get now the determinant which we deleted, which is now by deleting the first row and the first column. The second one will now be A12. So it will be now A12, which will now be minus 1, 1 plus 2. Determinant of A12. Like that. Okay. So now, if we are given the matrix, like that's the one which we just had here, the matrix A, example number 4, find all the cofactors Cij of A, which is equals to 1, 3, 5, 2, 1, 1, 3, 4, 2. 3, 4, 2. So let's get the cofactors here. So this is similar to submatrix. So we have, so the solution, there are exactly 9 cofactors in the matrix A. There are exactly 9 cofactors in the matrix A. And how should we get these cofactors? So using the definition, so to get the cofactors of Cij, then it is the same as minus 1 I plus j, determinant of Aij, determinant of Aij. So if we have this matrix, which is A to be equals to 1, 3, 5, 2, 1, 1, 3, 4, 2, then the first cofactor here, which is C11, is the same as minus 1 raised to 1 plus 1. Okay, minus 1 raised to 1 plus 1 by deleting the first row and the first column. And then now A11 will now be what? A1. So here, determinant of A11, which will now be determinant of 2 of 1, 1, 4, and 2. Are we together? So it is C11, which is minus 1, 1 plus 1 here, determinant of A11. And A11 is dividing the first row and the first, determinant of 1. Okay. So what do we get? So here, of course, since this one is 1 plus 1, so it is even, so this is positive. So we get here determinant of 2 minus 4, which is equals to minus 2. C12 is equals to minus 1 raised to 1 plus 2, determinant of deleting the first row and the second column, determinant of 2, 1, and then 3, 2, which is equals to minus 1. And then this is 4 minus 3 is 1, which is equals to minus 1. Okay. C13 is the same thing, minus 1, 1 plus 3, determinant of 2, 1, 3, 4, which is now equals to 1, which is positive. This is 8 minus 3, which is giving us 5. 2, 1 is found by deleting the second row and first column. So minus 1, 1 or 2 plus 1, determinant of 3, 5, and then 4, 2. 3, 5, and 4, 2, which will now be equals to, this is minus, this is 6 minus 20, which is plus now 14. It's 14. C22 equals to minus 1, 2 plus 2, determinant of 1, 5, and then 3, 2, which will now give us, this is positive, this is 4 minus 2 minus 15 is minus 13. And then C31, so C23, sorry, equals to minus 1, 2 plus 3, determinant of 1, 3, 3, 4, which we get this S. This is 5, this is negative, so we get 5 there. C31 equals to minus 1, 3 plus 1, determinant of 3, 5, 1, 1, which will now give us, this is positive, this 3 minus 5 is minus 2. C32 equals to minus 1, 3 plus 2, determinant of 1, 5, and then 2, 1, which will give us, this is negative, and then it gives us 9. And then finally, C33 equals to minus 1, 3 plus 3, determinant of 1, 3, 2, 1, which will give us minus 5. So that is how to do cofactors. Now, using the cofactors, let's now find, okay, we'll see that. We can use the cofactors to find the determinant there. So that is how to get the cofactors. So if we use the cofactors to find the determinant, so it is now, if you want to get the determinant of A, so determinant of A equals to A11 multiplied by C11 plus A12 multiplied by C12 plus A13 multiplied by C13. Okay. And determinant of A equals to A11, which is 1, multiplied by C11 here, which is minus 2, plus A12, which is 3, multiplied by C12, which is minus 1. And then plus A13, which is 5, multiplied by C13, which is 5. And what we get is 2. Now let's come to the next section, which is the row and column expansions. The row and the columns expansion. So we can actually use the row and the column to be the determinant. of the matrix. So we can use the row and the column to get the determinant of the matrix. Now, if we want to use the row 2.1, the row expansion. If n is greater or equals to 2, then the core factor expansion of determinant of A across the ith row is a determinant of A, which is equals to AI1, CI1 plus AI2, CI2 plus AIN, the CIN, which is the same as the summation of J equals to 1 to N, AIJ, CIJ. Now, if we want to use the row here, so if you're using the row, like what you just said here, we just use the row, okay, to expand. So if we're using the row, like what you just said here, A11, so we can say this is 1, so A11, A12, like that. Okay. So that is using the row. So you can say if we're using the first row here, so this is predetermined. So you can use the first row for the second. Okay. So what is changing here is the what? Is the column. So if you're using A1, so if I is 1, then what changes here is the J. So if I is 1, then it will be A11, the first one, A12, like that, up to the last one, which is N. N there. So we have used, so example number 5 is the one which we've just done there. So we can use, so find the determinant of 1, 3, 5, 2, 1, 1, 3, 4, 2 by the core factor expansion across the third. Let's use the third row. So let's use the third row. Let's use the third row. So this is like find the determinant. Okay. Find the determinant across the third row. Let's use this one. Third row here. Now, we already have, so it is now, this is the same as determinant of A will now be equals to, so the formula is A, so in this case, since we are using the third row here, then it will now be A 3, 1, and then C 3, 1 plus A 3, 2, C 3, 2 plus A 3, 3, C 3, 3. Okay, we're using the third row there. So A31 is equals to 3 multiplied by the core factor of 3, 1, which is minus 2, multiplied by minus 2, plus A3, 2 is 4, multiplied by 3, 2, C3, 2, here is 9, plus A33 is 2, multiplied by C33 is minus 5. Minus 5. Okay. And this is giving us minus 6 plus 36 minus 10. which is equals to what? Which is equals to 20. Now, again, we can use the column 2.2 column expansion. Now, if n is greater or equals to 2, then the cofactor expansion of determinant of A down the jth column is determinant of A equals to A1j, C1j, plus A2j, C2j, plus ANJ, CNJ, which is the same as the summation of I equals to 1 to n AIJ, CIJ. So we can expand across the column using the cofactors. So example number 6, we compute the determinant of 1, 3, 5, 2, 1, 1, 3, 4, 2 by the cofactor expansion down the second column. Down the second column. So the second column is this. So what you do here is determinant of A now is equals to 3. Now, in this case, which is, let's say, let's use this. So A, which is here. So A 1, 2, the cofactor is C12, plus the second one here is A22, cofactor is C22, plus third here is A32, C32, which will now be equals to 3 multiplied by C12. We found the C12 here to be equals to -1, plus A22 is 1 multiplied by C22 is -13, and then plus A32 is 4 multiplied by C32, which we found as 9. So this is equals to -3 minus 13 plus 36, which is equals to 2. So you can use a column. So you can use the first column, that later. So in this case, the remark use the cofactor expansion across a row or down a column that contains as many zeros as possible. So if you find that there is as many zeros as possible in some of the entries, yeah, then you can use that on close or down the column to get it done. So easy. So when we meet, we'll look at this example. Example number 7, compute the determinant of 5, 9, 2, 4, 0, 3, 5, and then 2, -4, and 7. Since we have 0 here, then you can use this way, or you can use this way. So you take the one which has more. Okay, let's meet on Wednesday. We continue from there.